Question 1 is about drawing diagrams and resolving vectors into vertical and horizontal components. As always, a sketch diagram is good enough. So 8.7 newtons, 32 degrees above the horizontal. We can see that we should have a horizontal component and a vertical component like this. The size of the horizontal component, I'm going to label it as H. So H is on the adjacent side, if I label it here as well. H is on the adjacent side. So we should remember from our trigonometry ideas that the cosine function relates the adjacent side to the hypotenuse. So H is a value of 8.7 times the cos of 32. That gives us a value of 7.4 when we write it to two significant figures. And the vertical component is 8.7 times the sine of 32. Which is a value of 4.6. They're both forces, so I should put a unit of newtons with them. Second one, a 91 millimeter displacement, 10 degrees clockwise of vertical. So we're up here. This is 10 degrees, and the size of this displacement is 91 millimeters. I haven't left myself enough space. So we can draw in our vectors, a vertical vector and a horizontal vector. So again, the size of the vertical vector, so not again, we're doing it in a different order. The size of the vertical vector this time, the vertical vector is on the adjacent side. So this highlights nicely that we don't just automatically go to one of these functions for vertical. This time it's on the adjacent side, so we can see it's next to the angle. So that must be cos of 10. So 91 times, oh sorry, not yet, 9.1, isn't it? 9.1 times the cos of 10 degrees is 8.96. So again, we're working to two significant figures. So to two significant figures, that's 9.0 millimeters. And the horizontal component, the horizontal vector, has a size of 9.1, and this time it's the side opposite to the angle. So that's sine of 10. Which is 1.58. So we're going to write 1.6 millimeters. The last one, a 52 kilometers per hour velocity on a bearing of 246. So again, so 246 is obviously about 25 or 24 degrees short of 270. So we could label the bearing as 246, or we could label something a bit more useful, which might be this angle in here, which is 270 minus 246. So that's 24, isn't it? Yeah. And the size of this is 52 kilometers per hour. So we're going to draw in our two components again. We've got a horizontal and a vertical. I suppose horizontal and vertical isn't necessarily a sensible name for bearings. Maybe a west and south would make more sense, but I've started now. So we'll stick to horizontal and vertical. So for the horizontal vector, we're on the adjacent side to the angle that we're going to use, which is this 24 degrees. So we're going to do 52 times the cos of 24. which is 47.5. We're still to two significant figures, aren't we? Up, so 48 kilometers per hour. And the vertical component is on the opposite side to the angle. So we're down here on the opposite side. So this will be 52 sine 24 which is 21.1, so 21 kilometers per hour.